Hey guys, so today's video is going to be a little bit of a two-in-one because we didn't get through everything that I was hoping to get through in class. So today's video is going to be a little bit of what we did in class Thursday and Friday. So you're going to see a combination of the product rule, you're going to see the product rule with positive and negative exponents, and I'm going to get into a little bit of the quotient rule so you'll have everything all together in one place. So here is what the problem of the day looked like on Thursday. So you can see we have 8 to the 5th power times 8 to the 4th power equals 8 to the 9th power. And the reason for that is because if we expand our expression, we can see that we have 8 written out 9 times. And the same thing down here. If I have 9 to the 3rd power times 9 to the 6th power, then what I have is 9 to the 9th power, and same thing. That 9 is going to be expanded out 9 times. So that's pretty straightforward. You guys didn't seem to have a lot of trouble with this. Then here is where it got to be a little bit more complicated. Let me put some paper over all the work I did here so I can walk you through it. All right, so if we had this problem, 2 to the negative 5th power times 2 to the 3rd power, we can still use our product rule. 2 to the negative 5 plus 3 equals 2 to the negative 2, because negative 5 plus 3 is equal to negative 2. Why does that work? Well, let's look at it here. Let me expand this. 2 to the negative 5 is 1 over 2 times 2 times 2 times 2 times 2 times, there's my times, 2 times 2 times 2 over 1. So once I multiply that through, what I'm going to have is 3 2's on the top and 5 2's on the bottom. And what you can see that I already went ahead and did was canceled out these 2's that are equal on the top and bottom, because all that's equal to is 1. So what I'm left with is 2 2's on the bottom. So what I have is 1 over 2 times 2, which as we said in class is equal to 1/4. It's also equal to 1 over 2 squared. It's also equal to 2 to the negative 2. So that I know that this is a lot, but this is kind of what you guys need to be getting used to. Not necessarily this, but the idea that all of these things are equal. We're just manipulating them and rewriting them into different forms. Okay, let's look at another example here. Here I have 8 to the 4th power times 8 to the negative 3rd power. So I can add them, I'll know what to expect. 8 to the 4th power plus negative 3 equals 8 to the 1. So again, I can expand that out. 8 to the 4th power, 8 times 8 times 8 times 8 over 1, times 1 over 8 times 8 times 8. When I multiply everything together, I'll have 4 8's on the top, 3 8's on the bottom. These 3 sets will cancel, and what I'm left with is 1 8. So my answer is 8 to the 1st power, or 8. Okay, we have one more example that we can look at. This one I can do with you in real time. So this one says 3 to the negative 2 times 3 to the negative 4. And again, I can add these two together. 3 to the negative 2 plus 3 to the negative 4 equals 3 to the negative 6, because 3 to the negative 2, negative 2 plus negative 4 equals negative 6. So I can do it that way, but I can also look at it in expanded form. 1 over 3 times 3 times 1 over 3 times 3 times 3 times 3 is going to give me 1 over 3 times 3 times 3 times 3 times 3 times 3. 6 3's under my fraction bar. 1, 2, 3, 4, 5, 6. So that's also equal to 1 over 3 to the 6th power. It's also equal to 3 to the negative 6, which is what we set up here. So again, all of this, it's all equal. We're just expanding it and compressing it so that we can see it in different forms. Okay, so that's the product rule, and that's what the product rule looks like when we have positive and negative exponents. So let's take a look at the quotient rule now. Okay, so here's the quotient rule. We're going to take a look at that. All right, so we're going to do the same thing. We're going to expand it. So I have 4 5 times. 1, 2, 3, 4, 5. And then I have 4 3 times. 1, 2, 3. So I have 1, 2, 3 4s that I can cancel out. what I'm left with is 4 times 4, which is equal to 4 squared. So something I'm noticing is that 4 to the 5th divided by 4 to the 3rd power, what was happening is that 5 minus 3 gives me 2. All right, so let's see if that works for this down here. So what I have here is 6 to the 4th power divided by 6 to the negative 2. So I'm going to apply my new rule. So 6 to the 4th power divided by 6 to the negative 2 should equal 6 to the 4 minus a negative 2. So what is 4 minus negative 2? Well, it's equal to a positive 6. Okay, so this is going to equal to 6 to the 6th power. And what about this one? So again, according to my rule, 2 to the negative 2 over 2 to the negative 4, it should equal 2 to the negative 2 minus a negative 4. And negative 2 minus a negative 4 equals a negative 2 plus 4, which equals 2. So this is equal to 2 squared. Okay, and I can only write those in one form because those are positive exponents. All right, so what is our exponent rule for division when given like bases? When given like bases, exponents being divided will be equal to the difference in the powers. So what does that look like as an expression? A to the B over A to the C is equal to A, B minus C. All right, I'm gonna do this self-check just to give you even just a few more examples of what this looks like. Okay, so 3 squared times 3 to the 4th power. That's pretty easy. I can just add my bases. Equals 3 to the 6th power. 9 to the negative 2 times 9 to the 6th power equals 9 to the 4th power. All I did was add my bases. Okay, here we go. 5 to the 4th power over 5 to the 7th power equals 5 to the 4 minus 7, which is equal to 5 to the negative 3, which is also equal to 1 over 5 to the 3rd power, or 1 over 5 times 5 times 5. And finally, my last example, 4 to the negative 3 divided by 4 to the 5th power is equal to 4 to the negative 3 minus 5, which is equal to 4 to the negative 8, which is equal to 1 over 4 to the 8th power. Okay, so I hope that answers questions. And if you guys have more, make sure you bring them into class.